Hello guys, welcome back. In this video we are going to talk about typecasting. So this is very important feature of PyTorch because sometimes we create tensors that we do not define the type in the beginning or when we initialize them, or we bring some of these arrays or from NumPy and we convert that. So there are lots of scenarios that we need to have the same type of tensors. The reason that we need that, so because also Python is not a type sensitive language, so we can pass everything in the function. So some functions like matrix multiplication or others, they require the same type. So even in that scenarios we need to have the same types of tensors. So let's create a tensor like T, and let's create it from torch, the tensor, and 2, 3. And 4, 5, 6. Let's print the type of this tensor. The type. The type is integer 64 or long. Now let's call it T1. And let's create T2, which is from a NumPy array. So torch.tensor np.array, and let's create a tensor like 10, 20, 30, and 40, 50, and 60. And let's print T2 dot dtype. Both of them are integer 64. Now let's say we want to change the type of T2 to integer. So one method is to float. One method is to use it like that. Let's say T2 equals T2 dot float. And now if we print T2 dot dtype, now it's float. Or we can create a float and we can convert it to integer. So let's say T1, we can just simply add decimals here, or we can use a data type. So dtype here, let's create a float, torch.float, this time float 32, and let's change the type to integer. So print or T1 equals T1 dot int, and now print T1 dot dtype. So here first we have float, then we have integer here, after changing to integer. Then this is for t2, which is already integer, and then we change the t2 to float, which is float 32. There's another method that we can use for typecasting, which is .to function. So let's bring this, let's create another tensor torch dot let's say zeros, and we can say 3 by 3. Now let's print the type of t3, t3.dtype. It's floats. Now let's change it to integer. So t3 equals t3.to, and here we can say torch.int. And int, it's an attribute. So now we can print t3.dtype. Now it's integer. So this is another method that we can use for typecasting. So actually Python converts data types automatically during operations sometime, and it converts to a bigger size of the tensors. So let's say here we have a float tensor, let's say TFL, which we can say torch.tensor, and we can pass, let's say 1, 2, 3, and let's define the data type. D type equals torch.float 32, and let's define an integer tensor t-int torch.tensor, let's call it 10, 20, and 30, and let's define the data type equals torch.int 32, and now let's create a summation of them. Sum equals t underline fl plus t underline int, and let's print the type of sum. So here print sum, that we can use either d type or also we can use type. Here let's say so now you can see that Python converts the data type to the bigger, because float has a bigger size, so it converts to the bigger size. But it's a good practice to define the types whenever we create tensors or typecast them. So some functions doesn't recognize that, and it makes some confusions for the program, and sometimes it gives us an error, which is very difficult sometimes to find it. So let's say we want to create a tensor with only one element. So let's call it scalar. And let's create it very similar to what we did for 1D or 2D tensors. Tensor of a number like 10. And let's print it. Print scalar. So it shows that it's tensor of 10, like that. But what if we want to access the number 10 or the integer 10? How can we do that? Because this is an object. This is a tensor object which with 10 value, with value of 10. To do that, there is a function called item. So let's say print scalar dot item. Now we have the real value of that tensor. So simply we can use it, let's say the value equals this one, and let's print value plus 1. It's 11. However, here we couldn't add it to 1, so